I tell you, I'm from the San Diego area, but it's taken coming to Xenia, Ohio to get a sunburn. Which after being here last year, I'd never expect. And I'm sure it happened waiting for one of those pork chop sandwiches. Can we give it up for the pork chop? That's amazing. Yeah. Well, I'm here to talk about AREDN, the Amateur Radio Emergency Data Network, which, from our perspective, is at the center of emergency preparedness. And it's our pleasure to be able to present at the forum again this year. A little bit of background to start off with. The ARRL commissioned a technical committee about 12 years ago or so called the HSMM Working Group. And they, which stands for High Speed Multimedia, by the way, okay? They defined some basic standards around the way you would run multi-megabit data within the ham microwave bands. And they did a lot of fine work. It didn't really go anywhere for a while until a group out of Austin, Texas, the Broadband HamNet group, which I was a part, wrote software for the Linksys WRT54G. These are the blue and gray routers that we still have in our garage. And they did good work. We ended up having a different priority, which was MCOM, and so several of us started the AREDN project here about 3.5 years ago. And what AREDN does is it takes commercial wireless ISP equipment, namely the Ubiquity line and the TP-Link line, and we have you strip out that software and load our software into it, and in doing so, it shifts the transceivers, the software-defined radios of these devices into the ham bands so we can use them under Part 97. That has lots of advantages. It's a very quiet band compared to the commercial Wi-Fi bands. It gives us things like 900 megahertz, 3.4 gigahertz. 3.4 has no commercial competition in the United States, so it's a very quiet, highly effective, long-range link band for us. We also make them operate under Part 97's unique requirements like call sign identification every 10 minutes and so forth. It does use the standard 802.11 protocols. The version of that protocol we use is N, which supports up to 144 megabits per second on these links. Now, not every one of our links will actually run that speed based on signal-to-noise ratio and so forth, but that is the theoretical maximum. And it also, these devices are self-discovering. So when you turn one of these devices on in a network, it sees the network, recognizes the network operating parameters, and self-configures itself to be a part of that network, and immediately then becomes an endpoint on that network. They're also self-healing, so that if you were to turn one off or move it away, the rest of the network recognizes that, and you're dropped from the routing tables of all the rest of the devices fairly quickly. It's designed by hams and created by hams for ham radio, specifically for emergency communications. Now, it has other uses, but our team is focused primarily on that use case. And today, if you ask the ARRL, I believe they'd admit that AREDN is really the preeminent implementation of HSMM from its original working group 12 years ago. And it's inexpensive for hams to deploy. Here's just a quick example. I'll show you some larger pictures of these in just a minute. You can see that on the least expensive side is a $45 nano bridge. These are actually available on the used market. Wireless ISPs have been using them for several years, and on eBay you can pick them up for 20, 25 bucks. Ranging all the way up to $150 for a rocket dish, which is at 5 gigahertz, that's a 30 dBi gain dish, and will support links up to over 50 miles. There's no network expertise required at the endpoints. In other words, if you intend to be an endpoint and deliver services at a disaster site or a deployed location, you don't need any network expertise. Now, that's a little different if you're wanting to design a backbone network in your area. Network expertise it does a lot for you in that case, but for the most part, and for the general ham that's interested in this technology, you need no network experience whatsoever. But what you are able then to deliver at these disaster locations is a real paradigm change for the incident commander and people there at the location, and we'll get into that in just a minute. So here's some general purpose nodes. Most of you have probably heard these names before. The Bullet and the AirGrid, which are single chain devices, and I'll describe that in more detail in a minute. And then the Nano Station, which is a dual chain, and the Rocket Dish, the Nano Bridge, two different types of nano bridges there, the Rocket Sector and the Rocket Vertical, all of which are dual chain devices. The difference is a single chain device operates in a polarization domain based on which way you have the antenna pointed or rotated. If the antenna is rotated horizontally, it's in the horizontal domain. Vertically, it's in the vertical domain. The dual chain devices operate in both of the domains simultaneously. And those of you that are familiar with the physics will understand that there's a 30 dB or so null between those two polarizations. So these devices take advantage of that and actually transmit different data on each of those domains. They're highly reliable and in that mode, and highly recommended by the AREDN team rather than the single chain devices. This is the Ubiquiti Air Router, which is a very handy device if you want to set up access to an AREDN network from a ham shack. It's actually a 2 gigahertz AREDN node with a built-in Ethernet switch, and we have defined the ports on the back of it to make it easy to connect other nodes to it and support a connection to the internet and so forth. So I mentioned we support Ubiquiti. The red ones are the ones that we don't recommend. The green ones are the ones we do recommend. And you look at the specifications, these things run from 23 to 28 dBm of power. You can see it's about 200 milliwatts to 630 milliwatts. And antenna gains based on which device you get or which antenna you connect to them, you can get from 11 to 30 dBi of gain out of those antennas. So doing the simple math of 630 milliwatts into a 30 dBi gain antenna is 630 watts of EIRP. So suddenly it doesn't sound as if it's your typical Wi-Fi router that you're familiar with not supporting the garage from the bedroom and so forth. This is a completely different world that happens to use the same RF protocol. You can also see the temperature ranges are quite extreme. These things will go down to minus 40. Most areas of the country don't get that cold. And then what we have found is when they do stop working and they warm back up again, they come alive again. I don't think we've tested that on the high temperature side, 176 degrees Fahrenheit. Okay, so how are you going to use this AREDN network? And this is really the crux of the remainder of the presentation is, what good is it, and then how as a ham do I actually build these things? So AREDN is designed for public service and public safety. That's really the focus of this Hamvention and the reason why I'm here to present today. That can manifest in several different ways. I personally am a member of the San Diego chapter of the Red Cross and part of their Disaster Technology Services group. And I have piloted with that organization this technology, and it's currently waiting for a disaster. And while I'm eager to see one, I'm not praying for one yet. So, but I may at some point. CERT teams, community emergency response teams, an effective way of using this technology. CERT teams can have backpack toted AREDN nodes with batteries and a tablet, and they could be taking damage assessments in their community and transmitting that back to the EOC for decision making and action. You can support memos of understanding with your local EOCs. I know that in San Diego it isn't yet being used for this purpose, but it would be suitable for supporting EOC communications with the local trauma centers for directing injured parties to get medical assistance. And the sort of services that we can deliver over this then are voice over IP telephony as an example, texting or chatting with other locations. We can actually install Samsung, Verizon micro cells at the shelter that will allow an incident commander to pick up their cell phone and get Verizon cell service from us. And when you think about what the roles we have played in emergency communications in the past, by passing voice traffic over VHF or UHF, I know of many hams that are disappointed that we're not in the message business anymore using this technology, but rather we're in the technology business providing the tools to the people that need to communicate. But this is the world, this is what the world will be like going forward, and I submit this is what the world is today. The expectation is not that I have to write a message down and have some level of confidence that it'll eventually make it to the other party. The expectation is that I can pick up the tools that I personally know how to use and use them for that purpose. And that's really, that's the paradigm change for the disaster responders and their organizations. We can also give them access to cloud-based services. We can, at a Red Cross shelter, for instance, we could set up a bank of laptop PCs and have the people that are impacted by the disaster come up and log in to their Safe and Well system, which is cloud-based, and let the world know that they're okay and that they don't need to be worried about them and so forth. And one of the important transitional, I see it as transitional services, is augmenting WinLink communications. WinLink is fabulous in conveying email messages over RF, any kind of RF, be it packet or HF. And AREDN mesh networks are no exception to that. And the thing that's really nice about it is you don't have the attachment limitations when you run it across an AREDN network. You can be sending X-ray images or I don't know, whatever via WinLink email over this. And WinLink has added a feature for us that makes it AREDN network aware, so that you can actually find the telnet nodes. And I'm not a WinLink expert, so you guys, if these are the wrong words, forgive me, but to find the WinLink resources on the AREDN network that you need to connect to, there's an automated way of doing that now. So within WinLink, you can see a list of those AREDN nodes that are delivering those services. So let's say you want to get involved in this. The first thing you'll want to do is to buy or borrow an AREDN node and fire it up. Go to the AREDN website. There's a map there, and that map will illustrate where the closest AREDN network is to you. And if it's in your community, then the map will also tell you what band it's using, which would suggest the kind of gear that you want to buy. And then turn it on and explore using the AREDN application. Find the network nodes that are in your area. The station IDs on the mesh status screen of that AREDN application will identify the call sign of the ham, that's the control operator for that node. Look them up on QRZ, send them an email, see how they're using the network, and whether your location might be a useful point for them, and get connected that way. If you find that there is no AREDN mesh in your area, then you may decide to be a pioneer, and we'll talk about what's ahead of you here in just a moment. So we've learned some lessons over the last few years. In New Orleans, as an example, this was really before AREDN was a possible technology, but there were some important lessons that could be learned from the hurricane there. Hams may not even get involved. I mean, you may have all the good plans in the world, and you may not be invited to the party. You may be relegated to serving food or some other service that's important at the time that has nothing to do with your primary reason for being there. And to me, this last one is the important one. Decision makers will generally always go with the safe solution. I've learned this a number of times over the last few years, that as good as the AREDN technology might be, and as confident as you may be in the ability to deploy it and deliver services to them, AREDN is not a particularly well-timed, tested technology. It hasn't been used in a lot of disasters yet. And because of that, it's a difficult decision for the commanders to make and the sponsors to make, is to deploy people to put a network in like this. In Puerto Rico, we learned that no installation is guaranteed, and it doesn't matter if you're Verizon, AT&T, or AREDN, or an amateur repeater organization. Mother Nature will define what will be there after the hurricane or the disaster has come and gone. Puerto Rico, and I guess to some degree New Orleans too, I'm learning, your own personal safety and even being able to count on law enforcement isn't an absolute. I know that I had put together a team of AREDN experts and offered it up to go to Puerto Rico. And one of the primary reasons it was turned down is they couldn't ensure the team's safety and what they wanted to do. But that was a lesson learned. And going forward, we need to recognize that. And oftentimes, deploying a post-disaster network is a better solution than deploying a pre-disaster network. By that I mean, it might be great to have a network up and operating to do fun things with, but if that network isn't going to be functional when the disaster occurs, then you might be better off building go-kits or building temporary deployment alternatives that you can put in place afterwards. The caveat there is the chicken and the egg conundrum, because you can't really convince a public service agency this technology is viable without having a demonstrable network to show off. So perhaps ultimately it's both. It's build the network to drill and to convince agencies that this is viable, and then all the spares that you have then would become sort of deployable part of the network that broke. Puerto Rico, I said I was a member of the Red Cross in San Diego. I asked the Red Cross if they would deploy us, and what I got in return is no, we're asking the ARRL to send a team to Puerto Rico. So even the Red Cross wouldn't look to its own internal membership to find a solution. They would go out. Again, it's the safe decision for them. And in Puerto Rico, the things that I understand were working were HF, portable VHF repeaters, and of course WinLink. It was obvious that a pre-disaster AREDN network would have been worthless because of all the devastation, all the towers are down, and so forth. And the other thing that was learned is that locals are much better suited at this than people that are brought in. Just getting equipment into Puerto Rico was tough originally. In 2016, I think it was 2016, there were a huge fire in South Africa. And this fire devastated what they call West Cape, which is a fairly highly populated, or several highly populated areas with lots of wildland, brush in between. And the fires took out all the communications infrastructure, which is a common event. But the local team had been experimenting with AREDN and had enough gear. They went ahead and deployed an AREDN network at each of the emergency services divisions, the police department, the fire department, and so forth. And there were 7 or 8 of these agencies that were all connected via AREDN. And it ended up being the only usable interagency service there was. So this was kind of the first feather in the technology's cap. We were blessed to have the ARRL write an article about it and give testimonials from the folks that were involved in it. So I'm going to quickly illustrate this. This is probably a familiar diagram for those of you that have seen my presentations before, but it does do a pretty good job of illustrating how this works. Let's say, for example, you are the Red Cross, and that's the chapter headquarters, and you have a disaster, and you send your disaster technical services group to deploy on that shelter, and they set up an AREDN node. And then there's a permanent connection from the Red Cross chapter to the closest backbone node, and then from that backbone node to the node that's closest to the shelter, a communications path is established between a data path, actually. And those of you that are thinking people would say, well, wait a minute, this means that you always have to have a clear view of a backbone node. So I'm going to introduce a third node type, which I'm going to call a relay node. And in the event the disaster can't find, or the shelter can't find a direct path to that, then this is a deployable node that can be placed somewhere where it sees the backbone node on the uplink and also at the same time sees the shelter node on the downlink side of it. And you would think, okay, well that solves the problem. It does, but it's not easy to find, to locate a spot where you can see both of those nodes. So the way that's done, and I'm not going to spend any time here today talking about this, we do have short forum presentations at our booth at Year 1001 where you can learn more about how this sort of thing works. But there's a tool called Radio Mobile. It's an online service that's put on by a very bright ham that knows about these things. And what it does is it illustrates the coverage area of, in this case, the San Diego backbone network. So all the areas that are green are areas that have a direct view to a backbone link. Now, if you ran a similar analysis for the shelter, and you looked at all those areas that the shelter could communicate with, and you overlaid those, then you could see all the areas where on the upside, on the uplink, you would have connectivity to the backbone, and on the downlink to the shelter. All right, so what makes up the backbone? Let's say you want to build one of these backbone nodes. And I just got done a few minutes ago saying this was inexpensive, so I'm going to shock you with the high-priced, the high-dollar items here. The two nodes on the very top are M3 rockets. Now, because M3s are operate at 3.4 gigahertz, that's not, and it's not a commercially viable product in the U.S. Getting them is expensive. They're almost twice as much as a regular rocket node would be. And then the 3 gigahertz rocket dish is also quite a bit more money. So for two of them, two combinations of the M3 rocket and the M3 rocket dish, you can budget about $640. The sector antennas, which are the antennas that distribute the AREDN network downward to people that are deployed. Those also, one for 3 gigahertz, one for 5 gigahertz. You'll spend about $588, something shy of $600 for those. You'll want a big battery. These things don't draw a lot of current, on average about 350 milliamps. But you've got 4 of them there, 4 times 350, you can probably survive for 75 to 100 hours on a 150 amp hour battery. But that battery's pretty big and it's pretty pricey. You'll also want a managed Ethernet switch so that you can remotely control these devices, look at operating parameters, and see where choke points are and so forth. 175 for that. You'll want to use commercial Ethernet cable that's certified for tower installation. The spool of that runs $150. And you need some means of keeping that battery maintained, either a float charge on it or recharging it should the power go out, and that'll run you probably $100. So it's going to cost a couple thousand in total for each of these backbone nodes, if you build it the way I'm suggesting. The good news is that if you're on the deployed side, like most hams will be, it's relatively inexpensive. A nano bridge or a power beam, you'll pay $88 for. You'll use a passive PoE injector, which costs you $5. If you're willing to wait for them to come from China, you can get them for $1 or $1.50. Another big battery, but this one maybe isn't quite as big. Maybe this is 100 amp hour. Maybe you can save some money on that. You'll need a Wi-Fi router to deliver AREDN services to the local community within the shelter. The incident commander can use his cell phone to connect up through the AREDN network if you give him a Wi-Fi connection. You'll need some Cat5 or Cat6 cable and a suitable mast or support. Now, that can be a lot of things. That can be a relatively inexpensive, the fiberglass army poles, a guide down. It could be an elaborate and expensive tripod and so forth. So I budgeted $100 for that. But if you figure out the inexpensive mast, if you already have the Cat5 and Cat6 cable, if you have your old Linksys WRT54G, there's your Wi-Fi router. So maybe you can get into this for under a couple $100. But this is really what makes up a Go kit to be an endpoint and to deliver AREDN data services. So here are some advanced pointers, and not all of you may be ready for these, but for those of you that are in the throes of designing a backbone network or implementing in your counties, I would encourage, if you're doing an endpoint, MIMO is a must. MIMO is the multi-in, multi-out. It's all the devices with the exception of the bullet and the air grid. Don't use those. Ham seem to be drawn to them because they're familiar with the end connector, and they say, "Oh, cool! I got an antenna that I can use with that." And the air grid looks a lot like a ham microwave wire dish, the old barbecue dish, but it's a bad choice. So high gain antennas really rule this technology. If you have a dish antenna that has a fair bit of gain, you may have a little bit more trouble pointing it and finding the sweet spot, but you'll have much higher signal-to-noise ratio and much higher data throughput. Nanostations are really sort of the workhorse of the downlinks oftentimes, because you can get 15 plus miles out of these things for $64 or whatever they cost. Nano bridges and nano beams will go further, 20, 25 miles. And the rule of thumb I use is to shoot for at least a 15 dB signal-to-noise ratio. If you get 15 dB of signal-to-noise, you'll have multi-megabit data connectivity through the network. Some don'ts. Don't use amplifiers. There is a way to use amplifiers, but I don't even think I'm qualified to, and I don't have the test equipment to make sure that they're being used correctly and not splattering across the band and just making enemies. And don't try to run links through vegetation. I've been told 900 megahertz gets through some, but I've also heard that it gets through none. And the higher you go, the worse it gets. So you really need a clear line of sight, and you need to be respectful of the Fresnel zones. I won't get into that discussion, but you can wiki it and find out everything you want to know about Fresnel zones. And don't be satisfied with link qualities under 100%. 100% links run great. They run to specifications. They run to people's expectations. 50% links are way too bad to be part of an effective network. So you need to plan for 100% links through the use of higher gain antennas and so forth. If you're building a backbone, again, MIMO is a must. You don't want to build it based on single-chain devices. You should also consider narrower bandwidths from the higher nodes to the lower nodes. The bandwidths to choose from are 5 megahertz, 10 megahertz, and 20 megahertz. And intuitively, you would think that a 20 megahertz wide channel would get data across more effectively. And the short answer is it would if you had lots of signal-to-noise ratio. But in practical application, you gain 3 dB of signal-to-noise by cutting the bandwidth in half. So going from 20 megahertz to 10 gives you a 3 dB improvement, and going from 10 to 5 gets you another 3 dB improvement. And for those of you that can do the math, 6 dB is an effective doubling of the link distance, and in many cases doubling of the data throughput. Don't expect downlinks to go much beyond 25 miles. And point-to-point links have been proven to be working up to about 50 miles. I don't know that anybody's tried to go any further. Don, are you aware of any links greater than 50 miles? Do you have? Okay, so, yeah, okay. So he's nodding. I can't hear you, but he's nodding. Yeah. And lastly, co-located nodes, where you have nodes on the same tower at the same site. They all have to be on different channels. To have two nodes on the same band and the same channel just doesn't work. And cell companies have figured this out. That's why your phones operate on a multitude of channels, and, as do the towers. Okay, I'm going to just quickly go through some photographs. Because everybody likes to actually see these things in practice. This is a node on Mount Palomar on the north side of San Diego County. It sits at 6,200 feet. And yes, we're blessed to have mountains in Southern California. But towers, be they water towers or communications towers, all serve similar purposes. And these are the sector antennas that provide services downward from Mount Palomar down to northern San Diego County, from Fallbrook, Oceanside, Carlsbad, Encinitas, and so forth. The photo on the left is the Otay node that's 50 miles south of the Palomar node I showed you just a second ago. And the two that you see identified there are one is the dish, the point-to-point link to Palomar, and the other is one of the sector antennas that are delivering services downward. You can't see it. There's another tower that sits behind this where the other sector antenna is. And then the towers on the right are a commercial installation overlooking Lake Elsinore in Riverside County, and I've got 6 nodes up there. And Don has a camera up there for ATV. This is Ventura County, Camarillo Hills. This guy's taken a tough shed, which that one runs about $800 if I recall correctly. I've got one similar. And he's put solar power on it, no doubt has batteries inside. It looks like it's a repeater site, and he's also, on the left you can see the sector antenna, on the right you can see the point-to-point dishes to connect to the backbone. Here's another example. This one's in the wild. Again, the characteristic dish antenna that connects you to the backbone, and then the distribution antenna in this case is sitting above it. Chatsworth Peak in Ventura County. I'm not sure this is one of the ones that was burned in the fire or not, this is actually 2 photos of the same site, one taken from behind and one taken from the side. You can see there's observation cameras on the tower as well that people will have access to. This one is in Mission Viejo on Saddleback Peak. It's in the wild. It's at a secret location. And you can see a California gray fox. They're interested in getting some shade underneath the solar panel. Water towers are another common high point. And the photos on the left illustrate a deployed node. Same node, just taken from 2 different angles. The one on the left illustrates the path to Mount Palomar, which is 15, 18 miles to the east. And then the photo in the middle then illustrates a nano bridge. That was a used nano bridge I got for $20, delivering services to the shelter site in the distance. And then the photo on the right is a business person who's also a ham who has set up a relay node in his office building by just suction cupping it to the window. That's pretty clever, appears to work. And then while you're proving this technology, you're also impressing local law enforcement through helping them with public service projects. This is some photos of the Swallows Day Parade in San Juan Capistrano, Southern California. These nodes are mounted on the back of trucks. They get the power from the car batteries. They have pan-tilt zoom cameras on each of them. And it gives the Sheriff's Department access to the entire parade route, and they can be looking for poor performers and making sure that the public is well behaved. And this is Don KE6BXT there at the controls. He's not only an active member and implementer of AREDN networks in Orange County, LA, Riverside, and beyond. He's also an avid ATVer, so you may know him from that community as well. And he's sitting in the back with a bright orange hat. We do have a large presence footprint here at Hamvention this year. We have, as I mentioned earlier, tutorials that are going on just about every hour, on the hour, and plenty of opportunity off the hour, at the half hour, for questions and answers. And, you'll find myself, Randy WU2S, who's also on the AREDN Project Core team. Mark N2MH in the back is our local expert on voice over IP telephony and other services. And we also have helping us out the Miami Valley Mesh Alliance, which we're very grateful for to help us out here. If you're a local, I encourage you to connect with the Miami Valley Mesh Alliance. We do have a network operating here at Hamvention. Actually, we have 3 of them. We've got one on 2.4, one on 3.4, and one on 5.7 gigahertz. So you're welcome to bring up your node if you brought one. The other thing I'd like to say about the Miami Valley Mesh Alliance is that they have managed to land some booth space for us. We're a volunteer organization. Coming to events like this is money out of our pocket. We don't have any income or donations from the work that we do. So we're grateful to DARA and the Miami Valley Mesh Alliance for allowing us to present here today, and also to have a booth that we're given actually for this purpose. Here's a list of the people on the team. There's a new one here that I have not described before, and that's Andrew, KK4ZUZ. And these are all code contributors to AREDN. Randy is in charge of promotions, and he's also our webmaster. And I call myself the project manager, although managing volunteers has little in common with project management as a profession, which I recently retired from. And before I close, I just want to cover a bit more about what our organizational and development priorities are. We've, to this date, been a bit of a closed group. Each one of us not only participates in the AREDN core team, but we also are building our own AREDN infrastructure in our respective areas. So we felt real comfortable about taking that experience and bringing it to a list of new features and functions that we thought were important. But we found over the years that that's not a very democratic way of producing open source software. So we are definitely moving much more to a more democratized development organization. We hope to be attracting and encouraging new developers, and Andrew, KK4ZUZ is the first example of that. We're also intending to put in place a more democratic and balanced review and approval process for what features get into releases and so forth. From a development priority perspective, the largest request we have, and we've had this for months, it is to make it easier to identify the device you have in your hand and the AREDN version that's on it. Based on the answer to those questions, you go through perhaps a unique procedure to get AREDN software loaded on it. And it's cumbersome, it's hard to document, it's even harder to get through. And so we are developing a tool that automatically recognizes the device, recognizes the AREDN, and loads the appropriate software onto the device, all hands off. So we're getting nothing but positive feedback on the beta testing there, and we expect it to be out shortly. We intend to add additional devices. Our current production release still doesn't support a lot of the Ubiquiti XW series of M products. And we have a nightly build which does support all of them, so we've done the development work. We're just struggling a bit getting it through testing and one final pesky bug that we would love to have resolved before getting it to production release. So we're hoping within weeks we'll be able to do that. We do intend to work on a new user interface to make it a more flexible tool for you, for those that are more advanced in networking, make it do more things. And we do want to explore alternative routing protocols as well. We have a network in Southern California that has upwards of 450 active nodes, and with as much changes that are going on dynamically within that network, the routing updates are consuming a fair bit of the available bandwidth. So we're looking at alternative routing protocols to solve that problem. And for more information, I've presented at a number of different symposiums, including a couple of TAPR Data Communications Conference proceedings, and you'll find them there in 2015 and 2016. There's YouTube, there's Ham Radio Now, other the news organizations with Ham Radio have interviewed us and have taken videos and presentations and so forth. And most recently, there's an article in the June QST that describes how to build networks like this. It's not exactly the same perspective as I've given you today, but it's also a real handy tutorial on how to get started with building the network in your county. So with that, I'll take questions. Yes, sir.
Question. So you said you're downgrading any recommendations for the bullet at the AREDN. Is that only because there's single polarization? And the second question is, what has been your experience in having the single polarization antennas talking to the MIMO antennas? Oh, good question. Okay.
So the question was, what's the objection to the single chain devices? So if you compare a single chain device like an AirGrid with a nano bridge, for example, the nano bridges will fall back to nodes or to modes that don't necessarily use the dual polarization MIMO technique. They'll fall back, to a diversity mode where you may drop bits on the vertical domain and yet they're picked up on the horizontal domain because the data is redundant in those cases. So they're much more reliable. It has everything to do with reliability of links. So then the follow-up question was, what happens when you take a single chain device like an AirGrid and on one end and then have a MIMO device on the other end? So I'm not personally up on the physics of this, but the symptom for this is often a link quality that's very high and the NLQ, or the opposite link quality, is low, maybe 0. And can it be solved in firmware? Perhaps. It's not on our charts because the solution from our perspective is to just simply not use the bullet and the AirGrid. And that may not be the answer you're looking for, but I think, from a development priority perspective, those times you don't have a solution, you need to get after one. But when there is a viable solution out there, then maybe it isn't as important. Any other questions? Yes, sir. So the question was, how is an AREDN network connected to the internet? If you have a local internet connection, then any node can, any node through a VLAN, a specified VLAN, can connect you to the internet. Now, a specified VLAN takes a little bit of network engineering into account. You would need to configure a managed Ethernet switch to put out that particular VLAN on one of the switch connectors, on one of the switch ports. But once you've done that, then you connect internet access to that Ethernet port, and it's then potentially made available to everybody on the AREDN network. Whether it is or isn't is configurable by you, and there's an option you check on the setup screen whether to extend internet access to the rest of the AREDN network or not. Now, if you choose not to, you still can have internet access to the one node that you're connected to. In other words, you can get all the benefits of internet access to that one node without extending it to the rest of the network. And the easiest way to do that is through the use of the air router. And that was the flat black device that had the single antenna on it that I said was a 2 gigahertz node that also has an Ethernet switch. In our software, we configure the back ports for internet, 3 of them for LAN, or the local area network, and 1 of them for DTD, or device-to-device networking, where you might plug in a 2 gigahertz node and a 5 gigahertz node via Ethernet cable, and you essentially merge the 2 networks into one. And any of those ports can be cascaded to other Ethernet switches. So you can take like the DTD port, for instance, and make it 50 ports if you wanted, if you had a 50-port Ethernet switch. The air router is really quite a powerful, handy little device, and it's cheap.
In my area, there's no public use of ours. So if one wanted to get started, how would you start?
So if there's no AREDN network in your area, in your neighborhood, how would you get one started? I would approach a club and see if you can get the club interested. Clubs oftentimes have repeaters that are on, antennas are on towers. It's looking good for, putting an AREDN node up there. Maybe start with a nano station and challenge other club members to pick up some of the inexpensive devices like the nano stations and see if they can connect to it. I will caution that if all you have in mind is building a network, all you get at the end is a network. And you need to also have in mind how you're going to use it. If it isn't for emergency communications and it isn't built around the sort of standards I described, if it's a fun thing, like maybe you want to webcast your club meetings to members and that sort of thing, then that's completely doable using inexpensive nanostations in a mesh configuration like that. Yes, sir.
Is there an active presence in the Bay or San Francisco Bay this year?
Is there an active presence in the San Francisco Bay Area? Yes. East Bay, Berkeley, South Bay all have active networks, and they're planning on expanding that east over into the San Joaquin Valley, which also has a pretty active group. Yes, sir?
The voice over IP phone like a branch network. Voice over IP phone to the network. So two phones on the network.
Okay, yeah, I'd encourage you to catch some of the tutorials that we'll have going on hourly, but the question is, how do you get two voice over IP telephones on the network? And I love the subject because it's such a powerful thing, but there are many ways of doing it. You connect two IP phones and you figure out what the address is of the telephone you want to call, and then from the opposite phone, most of them support IP dialing. You plug in the IP number and ring ring, you have a voice channel. Now, take that up a level in sophistication and it looks more like a regular telephone system where there's a PBX, but the PBX is running on maybe a Raspberry Pi and it's all done in software. So that you have all the features of a PBX like voicemail and extension numbers and trunking with other similar kinds of PBXs elsewhere in the network and so forth. There are lots you can do with voice over IP. Let me just take a quick check of the time here. Yeah, I gotta go. So it's been great. I'm sorry. I don't want to run over.